Okay, so let's look at this triangle here. It's a side-side angle triangle. So we know this angle here is 35 degrees, and then we have B is 8 and A is 6. Okay, and we're trying to solve the triangle. All right, so because we know alpha and A and we know B, we're going to use we're gonna try to find beta. Okay, so we're going to use this part of the law of sines. We're going to say sine beta is equal to, over B, is equal to sine alpha over A. And then we'll fill in what we know. So sine beta, because we don't know beta, over 8 is equal to sine 35 degrees over 6. Now, we're trying to solve the triangle to the nearest tenth. And so our chart would say alpha, beta, gamma, and A, B, C. Angles alpha, beta, gamma, sides A, B, C. All right, we know B is 8. We know A is 6. We know alpha is 35 degrees. That's all the information we know. Okay, now we can work this problem here. We would say sine beta is equal to 8 sine 35 degrees over 6. Now, how are you going to find beta? You'll have to use an inverse sine. So beta is going to equal inverse sine of 8 sine 35. I'm going to put that in parentheses because your calculator is going to do that, over 6. Okay? So I'm going to stop the recording so I can do that on my calculator. And I get beta, beta is approximately equal to 49.9 degrees. So, and you might be saying, oh, great, we know beta. There's a problem, though. Look at that beta. Look at the triangle we have. That beta is an obtuse angle. That means it's more than 90 degrees, and we didn't get more than 90 degrees. We only got 49.9. So what that means is there's another possibility that 6 could have been over here. Okay, so if you think back to the cases for side-side angle, that's one of the possibilities, is that side that you know could swing the other way. Okay, so where is the 49.9? I mean, that worked, right? It's right here. So this angle is 49.9 degrees. Now, you might say, well, that doesn't help me much. But it does. Because you have a measurement of 6 here, and you also have a measurement of 6 here, that forms an isosceles triangle. And in an isosceles triangle, when those two sides are equal, these angles here are equal. So you can find beta here because it's got to be supplementary with that 49.9. So if you take 180 degrees and subtract 49.9 degrees, that's going to tell you what beta is. And I'm thinking it's 100 and something. I'll just do it on my calculator real quick. Yeah, 130, oops, 130.1 degrees. Okay? So that is what beta is approximately equal to. All right, so we can put that in. Beta is approximately equal to 130.1 degrees. Make sure you put the degree symbol. Now, what about gamma? Well, again, you're going to take your 180, subtract 35, and subtract the 130.1. And I'm getting gamma to be about 14.9 degrees. Okay, those three angles still have to add up to 180. And then now all we have to do is find C. And so we can use C over sine gamma is equal to, now I would go with the alpha and the A because you didn't round off for those. So I would say A over sine alpha. And then that we can work out. We'll get, well, C over sine 14.9 equals, I think A was 6 over sine 35. Now you might be saying, hey, wait a minute, we weren't supposed to use a rounded off answer. We have no choice. We have to find C. So sometimes it just works that way. So C is going to equal 6 times sine 14.9 over sine 35. And there's going to be parentheses on these. Okay. I won't stop it. I'll just try to quickly put this in my calculator. And divide by sine 35. And I get 2.7. So C is approximately equal to 2.7. Now in this case, we don't have to do this other triangle here, okay? Because we know it's not that triangle. They gave us the picture. We were looking for this triangle here, okay? So if you're saying, hey, wait a minute, you didn't do two triangles, and there could have been two triangles. There could have been, but remember they gave us the triangle. So that other case, we don't care about that one. Okay,